Hey everyone, welcome to lesson 3.9, quadratic inequalities. So quadratic inequalities are based on the zeros, just like the equations are. And the main difference is that your answers will be intervals instead of specific numbers. So instead of saying something like x equals 2 is your answer, you might say something like 2 to infinity as your answer. That. Um, and there are four basic steps. The first one is the most difficult, and that is finding the zeros. You can use any of the methods we've talked about. Square root and factor are going to be the two most common. You can also complete the square and use the quadratic formula, but those take a little bit longer. As far as I know, I think most people prefer square rooting or factoring over the other two. And then once you find those zeros, you're going to put them on a number line. And you're going to use an open circle if it is less than or greater than, and a closed circle if it is less than or equal to, or greater than or equal to. You're going to then test each interval, and I'll show you what this looks like. It basically involves plugging in a number. And then decide which intervals are solutions. This is based on whether they are positive or negative, and whether or not the question says greater than 0 or less than 0. And then you'll write your answer in interval notation. One quick review thing that I want to say over here is that if it says less than 0, that's negative numbers. I know that we all know that negative numbers are less than 0, but sometimes putting these two things together is a little tricky. And if it says greater than 0, that means you want anything positive. Okay. Let's look at this first one together. We have x squared minus 5x minus 14. Because there are three things, you're probably going to want to factor this one, meaning you need two numbers that multiply to negative 14 and add to negative 5. Those two numbers just happen to be positive 2 and negative 7. Because 2 times negative 7 is negative 14, and 2 minus 7 is negative 5. Then you're going to want to write your answers. So your zeros are negative 2 and positive 7, because you want the numbers that make this 0. So negative 2 plus 2 is 0, and 7 minus 7 is 0. If you remember back to when we factored and we solved by factoring, these always flip. They're always the opposite. Then what I'm going to do is I'm going to come over here and draw myself a number line, and I'm going to put negative 2 and 7 on that number line. And since this is strictly less than, not equal to, I am going to go ahead and put an open circle on both of them. And then I'm going to pick a number in each interval to test. So over here on the left side, I'm going to pick the number negative 3. And I'm going to take negative 3 and I'm going to plug it into each factor. Okay? So it's way easier if you check each factor instead of plugging it back into this long thing, because negative 3 plus 2 is negative 1. And negative 3 minus 7 is negative 10. And then I just have to multiply those two numbers together, and I get a positive 10 as my answer. You could also plug it back into this equation right here. I'm just going to say that one more time. I am plugging it into this. That's where I substituted the negative 3. So negative 3 plus 2, negative 3 minus 7 is 10. Then I'm going to do the same thing, but I need to pick a number that is in this interval. So anything between negative 2 and 7. I'm going to make my life easy and pick 0. 0 plus 2 is 2. 0 minus 7 is negative 7. And 2 times negative 7 is negative 14, which is a negative number. So really, all you actually care about is whether the answer is positive or negative. Okay? When we are testing, we are worried about whether it's positive or negative only, because our answer is based on whether it's positive or negative. Okay? So I don't need to write 10 up here, I just need the fact that it's positive. So once you see double negatives, you can automatically assume positive. You don't actually have to do the work of multiplying it. And this one only has one negative, so that's going to be a negative answer. And then at the very end, let's see, I need a number that is greater than 7. So I'm going to pick 8. 8 plus 2 is 10. 8 minus 7 is 1. 10 times 1 is 10. That's a positive number. I'm always going to find this number for you guys, or I at least did on this problem, so you can actually see it. You're basically just plugging in a number. And if you do the factors like this, you can kind of just do mental math. Negative times negative, it's positive. Plugging in 0, positive times a negative is a negative. So you don't actually have to find the number there. Then I'm going to go back to my original problem. You always have to go back to the original here. This says less than 0. That means I want my negatives. And my negative is only here in the middle. So this area right here is my answer, from -2 to 7. And it gets put in parentheses because those are open circles. That is my final answer. All right, let's look at another one together, and hopefully this will kind of start coming together a little bit. This one has parentheses. And if it already has parentheses, you probably don't want to factor it like this. Instead, what you want to do is get the thing that's being squared by itself. So I'm going to add 16 to the other side. And I'm going to cheat a little bit, and I'm just going to cross it out and write 16 over here. Okay. And then I'm going to take the square root of both sides to get rid of that squared. But when I do that, I have to write my answer. And I guess I'll keep that sign. It doesn't matter if you write an equal sign or if you keep this one. When I do that square root of 16, it's going to be 4, but not just 4 plus or minus 4. Because whenever you do the square root of both sides, you have to add the plus minus. Then I'm going to add the 5 to the other side. Like this. So it'll be 5 plus or minus 4. So my zeros are 5 plus 4, which is 9, and 5 minus 4, which is 1. There you go. Now we just put those on a number line. 1, 9. And we pick a number to test for each interval. So for this interval, I'm going to pick 0. And there's no factors to plug this one back into. So what I'm going to do is plug it back into this equation right here, the original. 0 minus 5 squared minus 16. That will be -5 squared, which is 25. 25 minus 16 is positive. It's actually positive 9 if you're curious. Then I need to pick a number between 1 and 9. Again, I'm going to make my life easy and just pick 2. And this time, instead of 0 minus 5, it'll be 2 minus 5. So whatever number I'm plugging in for x goes right here. 2 minus 5 is -3. -3 squared is 9. 9 minus 16 is -7. So this time it's a negative. And I'm going to kind of repeat this because I have a feeling some people might be getting confused. I don't have the factors like I did up here. So instead, I just have to plug it back into what was the original equation. X minus 5 squared minus 16. So it's actually a lot easier if it's in factored form. And then I need a number bigger than 9. I'm just going to go with 10. So I have 10 minus 5 squared minus 16. 10 minus 5 is 5. 5 squared is 25. 25 minus 16 is 9, which is positive. Then I'm going to look back at my original problem, and I forgot to draw an open or closed circle. There's no equals to, so I'm going to draw an open circle real quick. And this one says greater than 0. So because it says greater than 0, that means I want my positives, which is going to be this area over here and this area over here. So from negative infinity all the way up to 1, open circle, so use parentheses. And from 9, open circle, use parentheses, to infinity. So sometimes it's the middle part, and you only need one interval like this. And sometimes it's the outsides, and you need 2 intervals like this, which we've seen before. All right, moving on down the list. This next one scares people a little bit because it looks kind of complicated. These two, both first ones, had zeros on this side first, so we want to make that happen in the beginning. So I'm going to subtract this 2x squared. Notice how I'm lining it up underneath the other x squared, and then this cancels and becomes 0. 3 minus 2 is 1x squared. And then we can factor this. It's got 3 pieces, so we want to factor it. I need 2 numbers that multiply to negative 40 and add to 3. And that's going to be positive, I almost wrote the wrong number, positive 8, negative 5. So then my zeros are negative 8 and positive 5. We're going to go put those on the number line. And this time, I'm going to use closed circles because it's greater than or equal to. And this one does have a factored form. So when I plug in, let's see, something to the left of negative 8, let's go with negative 9. Negative 9 plus 8 is negative 1. Negative 9 minus 5 is negative 14. So you basically have 2 negatives. That makes a positive. See how I don't even worry about what the number is, I'm just worried about whether it's positive or negative. And then I'm going to plug in 0. So that's between negative 8 and 5. 0 plus 8 is positive 8. 0 minus 5 is negative 5. A positive times a negative is a negative. And lastly, something bigger than 5 is 6. 6 plus 8 is 14. That's positive. 6 minus 5 is 1. That's positive. And a positive times a positive is a positive. Hey, if that bothers you and you would rather write it like this, and write the actual numbers, that's totally fine. I'm just picking the signs. So that way I'm saving myself a little bit of headache. Okay. And then this one had a greater than or equal to 0. I guess I'll box it right here so easier to see. That means that we want the positives, which are on the ends once again. They aren't always on the ends. You do actually have to look. They are commonly on the ends. So over here, negative infinity to negative 8. But use a bracket because it's a closed circle on the 8. And then 5 to infinity. Use a bracket on the 5 because, again, it's a closed circle. And then the last one at the bottom only has 2 terms. And you can actually factor this one or use the square root. I'm going to show you how to do the square root because I don't know if we've done one exactly like this before. So I'm going to add that 9 to the other side. I get 4x squared less than or equal to 9. I'm going to divide by 4. And I'm running into an issue because 9 doesn't actually divide by 4. So what I'm going to do is just leave it. And I'm going to go ahead and take the square root. Now, when I come over here to do the square root, I can either do the square root as one big square root, or I can do the square root of 9 and the square root of 4 individually. And I'm going to do that because the square root of 9 is 3, and the square root of 4 is 2. And then because we did the square root on both sides, we're going to put that plus or minus. So these are our zeros that we're going to put on our number line. -3/2 and +3/2. Okay. Something to the left of -3/2 is -4/2 or -2. And this is one that doesn't have factors, so you kind of just have to plug it in. -2 squared is 4. 4 times 4 is 16. And 16 minus 9 is, I don't know why I can't think of this, 7. Man, my brain's not working today, guys. Again, I did -2 squared right here. That's where this 4 came from. I know somebody's wondering that out there. That's a +7, so my answer is positive. I can plug in 0 between -3/2 and 3/2. And that's going to be 4 times 0 squared is 0 minus 9. 0 minus 9 is -9. And I'm going to pick +2 over here. 2 squared is still 4. That's where I'm getting this 4 right here from. This 4 is the 4 out front. This is 2 squared, and this is the -9 at the end. That's 16 minus 9 again, which is 7. That's a positive answer. Coming back to my problem, it said less than or equal to 0. So I'm going to use closed circles. And I want the negatives, which is this part right here. And one thing that I'm going to show you at the very end before we move on is you can shade in between these if you want, like we used to, like that, and like this, or draw an arrow, connect them with a line. That's fine too. Over here, I could do this. That's how we used to graph our inequalities. You can still do that if you want to. I really care about this interval notation, though, and to see your test values. Okay, now let's talk about a slightly different but very similar approach. And that is solving them graphically is what this one's called. In solving them graphically, I almost copied and pasted these steps exactly. The new step is that instead of choosing test intervals or test numbers, you're going to sketch the parabola. Okay? And this basically means that it's going to go up or down. That's basically what you need to decide. Okay. And I'll explain how to do that down here. I'm not going to write it out though, because it looks more confusing if you try and write it out in words. So on this first one, see how there's a number in front of x squared? This is the type of factoring where I have to multiply first times last, which is -18. And I need two numbers that multiply to -18 and add to -3. That's going to be +3 and -6. And when there's a number in front of x squared, you have to split it up like this. You can't go straight to the parentheses. And then you're going to try and factor this, taking out an x. and factor this, taking out a -3. Now my parentheses match, which means I put that out front. And in the other parentheses, I put what was on the outside, which is x minus 3, leaving me with zeros of -3 divided by 2 and +3. So you always do the opposite, and then if it has a number in front of x in the factor, you divide it like that. So what I'm going to do now is come over here to my number line, -3/2 and 3. And I'm going to go ahead and put these as closed circles because there's an or equals to. And then you have to look at this number right here. If this number is positive, the graph goes up like this. If this number is negative, then the graph goes down like this. Since it's positive, it's going to do this. So I'm just going to draw a parabola through these. And that basically tells you that this section is positive because it's above, this section is negative because it's below, and this section is positive because it's above. And since this says greater than or equal to, we want these parts. From -infinity to -3/2, bracket because it's got a closed circle, and 3 to infinity. Again, bracket because it's got a closed circle. So it's just an easier way of seeing where it's going to be positive or negative other than testing the values. And a lot of you know how to graph them really well, so this is probably easier for you. And then this very last one has one slight trick to it, and that is that there is a negative out front. So what I'm going to do is take it out as a greatest common factor, like this. You can't just get rid of it, you have to put it out front. And then I need two numbers that multiply to 8 and add to -6. That'll be -4 and -2, leaving me with zeros of the opposites, 4 and 2. So I'm going to draw my number line. I'm going to put 4 and 2 on that number line with open circles because there's no equals to. That negative means that this graph is going upside down, like this. So we have negative, positive, negative, because it's below over here, which is negative, and above over here. So think of this as like the y-axis, like this, going through the graph. These would be this is in the positive area of the axis. Since both of these go below, these would be the negative y values. So we want greater than 0, which is positives, this area right here. Because over here is in the negatives.